Welcome back to Clean Code in the Browser. In the last part of the episode, we let Evil Chris write some implementation code that was, well, evil.
Hey, that code was beautiful. I actually printed it out and had it framed. You'll get the bill at the end of the week.
We outlined some ways that we could apply single responsibility principle and command query separation to this code. So now, we're going to jump right in and actually implement those changes.
Ha! Good luck improving upon perfection.
All right, so what I want to do with this is first I want to extract these pieces of logic out into different classes based on who the change agents are. And so we see that we've got this templating report logic that would be changed by the business user, and we have this persistence layer that's definitely like a developer concern. So let's break that out first. So really, the paint class shouldn't need to worry about persistence. That's something that ought to live elsewhere in some kind of like a store class. So I'm going to create a paint store. Constructor. And our paint store is going to take care of a lot of this logic, right? Because for the most part here, we are setting up the store and then setting up some data here. So really, we don't need that at all. What we do need is the ability to tap into the store. So here we can see that we're fetching a color from the store. So we need some kind of, let's just say get. So I need a get function that's going to take color. And then I'm going to return this .data using the color. And that should give me the get. So here we're going to say, well, in this right here actually is logic about what to return if we don't have any information about the color. If color is missing from data, then we want to just use max uses. So that's something we could actually put into here. So let's do, so it's either this data color or it's going to be max uses. And so we'll return that 8 number if we don't have any information about that. And we don't really need to worry about persisting that. So we should be able to delete this entire thing here. Next, here's the actual query part, right? And so here is where we're going to do this store get the color. Now we don't have this store, do we? So probably want to pass in a store. And over here, that means that we're going to need to create a store. So we've got a paint store that we're going to be requiring from the same file for now. And we'll do new paint store. Is going to be what we pass in. Then let's see here. So we're using the store to fetch that color. Now here is where we are setting things. And so we want to keep this logic but have some kind of a set API. So we're going to set the color and some kind of a value. And here we're going to say this .data color. We're going to set it to the value. And at this point, we would want to use local storage. We're going to set item paint to this .data so that every time that we're setting, we are in fact persisting this. So we are getting, we are setting. So here we're getting the current value so that we can determine whether or not we have any uses. So let's change this to this .store.get color, and we're going to subtract the number of uses. That's going to give us the number. So we'll do new uses. We'll do this .store set. The color is going to get set to new uses. And then, yeah, we don't need this local storage stuff because that's being handled in the store itself. Oh, well, way to go. You just broke the tests.
Well, okay, let's take a look at this. So it looks like we're requesting keys of a value that's not an object. Coming down to our report, it looks like
Yeah, so we're still accessing this .data. We were trying to get the entire data so that we could grab the colors, which are the keys, and iterate over those. So we need a different way to do that now. It looks like it would be helpful if we could ask our store to give us all of the data rather than just a single color. So let's try get all, and this will just return this .data in its entirety. And then down here, we'll swap this out for this .store.getAll. And I think the rest should work as is. All right, so we're back to passing.
So let me guess, you're just going to write another class, as if classes just grow on trees or something like that.
Yes, actually, that's exactly what I'm going to do. I'm going to create another class. So we probably want to have some kind of a report class, probably a paint report class here. So let's say that we're going to return a new paint report. We probably want to use the store in order to pass in like all the data so that we can render that out. And then let's say that we're going to have some kind of a generate method that's actually going to generate the HTML content. So up here, we're going to create a new class because after all, they do grow on trees apparently. Paint report. It's going to have a constructor. The constructor is going to take data, and we're just going to put that into data. And then the code here, we all want to put into the generate function. There we go. We've got all of that. And then we're going to still need to have get report row. Now, get report row has a few things from the paint class that we're going to need to fix. So the first thing is that it has this .store.getAll, which we can change this to this .data because that's going to be the same thing. And then it no longer has access to the get paint color left or like get paint left, but we can change that to this .data, just accessing the color, and that should work as well. And let's see if that did the trick. Looks like that passes. Great.
All right, hotshot. So it looks like you've got SRP covered. But what about command query separation?
Well, it's true. We do want to take a look at command query separation here because get report row, we want that to be a query function, and yet it's changing state in 1, 2, 3 places. This can definitely be improved in order to get more clarity into the code. So we first need to take a look at what the state is that is being changed. We have this idea of the report being done, of being in the header. Both of these, given the fact that we now have a paint report that's being fired up and then thrown away when it's needed, and then when we're done with it, keeping track of this intermittent state is probably not necessary. We can probably do better than that. The reason that we're keeping track of report done is just so we can do this while loop. We can loop over get report row until we're done. We can probably do a better iteration than this. Really, we want to be able to iterate over each of the colors, creating 1 row per color. Once we're out of colors, then we're going to move on and be done. So really what I want to have is some kind of an each color function. And it would be something that would take a function, and we would be iterating over the object keys of the data, since that is the set of colors that we're using. And so this would be our colors. And then we want to do colors dot for each. We're going to loop over these. We're going to have a function that takes color. And then we want to grab the value as well so that we can make that available to the function that uses each color. So that's going to be, let's see here. So the value really is the remaining number of uses that that color has. So the remaining is going to be this data at index color. And we want to then run our function, passing in both the color as well as the remaining. This would then allow us to get rid of this and do something like this dot each color, and it's going to get color and remaining. And then here we would want to Since we're currently building onto this.report, we would want to do get report row, have that spit out a row. And at this point, we're going to want to actually pass in the color and the remaining, whereas before it was trying to figure out what color and remaining was from inside of the function. So now we need to update get report row so that it takes color and remaining, which means we no longer need to calculate color and remaining. It means the color is always going to be present, so the else here is never going to come up. We're never going to have to worry about that. Remaining, we already know, so it's just going to be this output line. So the next thing that we need to wonder about is this header, because here we're keeping track of whether or not we're in the header, and if we are, we spit out a header and then we change in header to false. But we could probably pull that out into its own idea. So if we did get report header and then made that something like this, where we're just going to return that value, we want to say this dot report plus equal this dot get report header. Now we no longer have to worry about the header case inside of get report row, and actually all of this ends up kind of being junk because we don't need any of that. We no longer need to manipulate this dot report from inside of here, and we're down to a single line. We're just going to report a row, which makes sense. That's what the function says it does, is get report row.
Okay. Really prolific stuff you've got here. Are we done? Can we just get out of here?
Well, 1 second, because I still want to fix this get paint left. It has both a side effect and a query. We want to extract those apart. And when we look at the way that we're using it in our test, we're not getting a return value. We don't really care. So rather than thinking about it as get paint left, it's really more about like using paint, giving it the name of the paint and how many units were being used. And so let's implement that over here. So we're going to have use paint. And this is, again, going to take color and the number of uses. And we're going to steal these guys here. And actually, new use isn't really correct. It's remaining. It's the number that we have remaining here. So it's going to be either the number that we have minus the uses, or it's going to be 0. And then we'll put remaining here. And then as far as getting the paint left, we're just going to get that data. And so this is going to extract those two apart. We'll make sure that we are still passing. And yes, we are still passing. We're looking good. And so we've effectively gone through the simple code, but we've managed to detangle it. We've used SRP in order to take the concerns, separate them so that different agents of change would affect different parts of the code base, specifically if we moved these classes out into separate files. And then we were also able to use command query separation in order to make sure that it is very clear what each of these are doing and there's no unintended side effects.
Whew. I don't know about you, but I am beat. I'm hungry. Want to grab something to eat?
Yes, we should get something nutritious or organic, something that will leave us feeling good. Yes, we should get some Taco Bell.
No, we're not going to... Well, actually, I could totally go for some tacos right now.
Taco Run!
Okay, so you got the hard taco, right?
Thank you.
And the nachos, no sour cream.
Oh. Did you forget the fire sauce?
Yes, I've got the fire sauce right here. Calm down. Regardless of what you think about Taco Bell's cuisine, you have to admit, they have a clever way of building their menu. I mean, the majority of the items that they have are all composed of just a few simple ingredients. Tacos are meat, lettuce, cheese, and a tortilla. Double-decker tacos are a taco with beans and a second tortilla slapped on it. Nachos are chips with taco fixings dumped on top. Quesadillas are tacos with the cheese melted and no lettuce. And on it goes. I think it was maybe 6 or 7 years ago that I first heard someone refer to Taco Bell programming. The idea was that in the same way that Taco Bell creates a whole menu of foods that are only made out of a few ingredients, we as programmers can create a myriad of programs composed only of a few small, simple building block programs. This fits very well with the Unix philosophy. Build small programs that do one thing well, and then compose them into higher order programs. If these programs also do one thing well, they can be used as a building block for an even higher order program. Taco Bell programming sees code as a liability, not as an asset. And so when building programs, you want to get as much functionality for as little code as possible. Now you can do this by creating simple, easy to understand, easy to reuse programs, putting them together, and creating a high amount of confidence with low errors.
Yeah, with code that simple and clean, even I can't screw it up. And I'm evil.
Now, I can hear what you're thinking. You're saying, Chris, that sounds great, but I can't write all of my code as shell scripts. And you would be correct, you cannot, nor should you ever want to do that. I mean, I don't often see grown men cry, but when I do, it's usually because of a bash script.
Oh, shell scripting. Now that is really evil.
Evil might be overdoing it a little bit. How about powerful yet arcane? But the good news is that Taco Bell programming can be applied to any development environment by borrowing the idea of functional composition from functional programming.
Functional programming? That's just for academics.
Oh, will you please just stop? There's nothing academic about forming higher order functions out of lower order functions. And if you're already using SRP and command query separation, then there's nothing stopping you from using functional composition in your current environment. It doesn't have to be a purely functional environment.
Well, I'd like to see that.
Well, you're in luck. Let's take a look and see how functional composition techniques can be used in JavaScript.
Continuing on our previous paint example, let's say that the stakeholders get back to us. Unsurprisingly, they are looking for more reports. Specifically, what they're looking for is a report that is going to give them the 3 lowest non-zero paints in ascending order so that they know what are the paints that are almost out. So we have a test that shows that we're going to use a bunch of paints, and they're looking to see the 3 paints that have the least amount left, but still have at least 1 unit left. And we're going to need some kind of a function that will give us the data for these almost out paints.
Well, sure. I mean, that looks pretty easy. All you need to do is fill in almost out data. Just slap some code in there in order to meet the requirements, and then we'll get on with our day.
Well, it's not a totally unreasonable idea. We could just implement almost out data here. But what we want to do is we want to try some of this Taco Bell programming. We want to try some functional composition. So given that, we're going to create a new module that has some very small functions that we're going to use to build up this capability. So to start with, we've created a couple new files. We've got paint data, which is going to be a module of functions that we'll be able to compose together to give us the kind of data that we need. And we have a test file for it as well. The first piece of functionality we want to build out is we know that we need to take the existing data format and change it into something that's going to be sortable. Right now we have an object with keys that are the color names and with values that are the remaining paint units. And we need to get that into an array, something that's going to be sortable so that we can make it ascending. So implement this here. So we can do object.keys for that. And once we've got the keys, then we're going to be able to map over that and create an array, and we want the key, and then we want to have the value at that key there, and we'll need to return that. And let's see if this gets us to a passing state. Okay, so this is the original function that was failing, but this new function is passing. Next, we're going to implement the remove zeros function so that we can take all of the tuples that have 0 values and pull those out. So we can start off with some kind of an output, and we're going to take our tuples and we're going to loop over them. Inside of that loop, we're going to say that if the value of that tuple, let's say if it does not equal 0, then we're going to push on the tuple. All right, and then we'll return not the tuples, we're going to return output at the end. Let's check and make sure that that passes. Great. Next up is the sort ascending function. We want something that we can pass in an array of unsorted tuples and get back an array of tuples that are sorted by the remaining paint value. So to do this, we can use the existing tuple sort function. This takes a function that has an A and B value. And out of that, we need to get the remaining value. So we can do value A equals A index 1, and we'll do B. And then we want to take a look at these, and if value A is greater than value B, then we need to return a positive 1. If it is less, then it's going to be a negative 1. And if these guys are equal to one another, then we're going to return a 0. And it looks like that passes. Finally, we want to implement a take function, something where we can pass in an array of tuples and take the first n. In the test, we can see that we're going to take the first 2 and expect to just get blue and red. So this one is going to be pretty easy. Really all we need to do is we need to take the tuples. We're going to do slice, start at 0, and we want it to be of n length. And that should give us what we need. We'll double check the tests. And the test passes. Now we're ready to go over and implement the full function. So now that we have all the individual Taco Bell ingredients, it's time to make a taco or a quesadilla or something. I've imported these 4 functions that we're going to use below. So we'll grab these. And the first thing that we need in this almost out data function is we need to get the data. And so we can get that from the store with the get all function. Then we want to get tuples because right now the data is an object. So we use that object to tuple, passing in data. Next we want to pull out those zeros, passing in the tuples. We're going to make it sorted using the sort ascending. And finally, the return value is going to be taking the first 3 of the sorted. And with any luck, these should pass, and we should see all passing tests. And we do. We successfully took all the Taco Bell ingredients and composed a new function that gave us this functionality. Now that we've successfully gone from red to green, I do want to take a moment and do some refactoring here, because the code's not quite where I'd like it to be. We're creating all of these variables that are pretty much just being used on the next line. I wonder if there's a way that we can clean that up. Certainly one possibility would be to do something like return take 3, and then here we would just directly do sort ascending, and here we would do remove zeros, not event listeners. And then inside here we do object to tuple, and then in here we do this store get all And these would all just kind of be nested together in a single line. While that gets rid of the variables, it certainly doesn't improve our legibility one bit. Probably makes it worse. But I'd really like some kind of a syntax that demonstrated that this is one composed idea. Now, if we were working in the shell, doing Taco Bell programming, we would probably be using pipes in between different commands in order to pipe out the output of the first command as the input of the second command, and the output of the second command as the input of the third command. In other languages, like Elixir, for example, they actually give you a pipe operator, which is pretty neat. It allows you to do something like this, to store to get all, and then we're going to pipe the output to the next function, which would be object to tuple, and then we could pipe the output of that to be the input of remove zeros, and we could pipe that, and on this goes, and you're able to very clearly show that we're kind of passing this data through a series of functions or filters in order to then get a final result. Now, unfortunately, we don't have the pipe operator here in JavaScript, although I have seen that for folks who are using Babel, there are some Babel plugins that add it to the language. I'll leave it to you to decide whether or not that would actually be a good idea. But the good news is that this isn't too difficult to do in plain old JavaScript just by creating a new compose function. Coming back over to the paint data file, let's create another exported function called compose. Now there's a few different ways that you can do this. The way that I want to do it is to have it take a number of functions, and we're going to just run function after function, taking the previous output and using it as the input for the next function. So we're going to start with a result, which is going to start out as null. And then we're going to use funcs for each, looping over these. And we're going to update result to be the function passing in result. And so that way we will use it for the function and the output will be the input for the next one. And then at the very end, let's return the result. Coming back over to our index file, now we need to get the compose function from this import and use it down here. So now we're going to return the result of compose, and we need to put in some functions here. So we need this.store.getAll. Now, the way that we wrote this actually won't work because of how the functions are bound and the environment they're getting called in, but that is easily remedied just by creating a little anonymous function here that then calls this.store.getAll. We then have object to tuple. We have remove zeros. Store descending. And then here, this is another tricky one because we can't just use take. We also need the number of things that we want to take. So again, I'm going to use an anonymous function, and this one will be getting some tuples, and we're going to take 3 and the tuples. We should be able to delete all of this, and let's see if we are passing. Great, we're still passing. And so I think this is probably easier to read, and there's other ways that you can do this kind of technique as well. But by just using a few functional composition techniques, you can definitely improve the legibility of your code.
Oh, well, there you have it. Taco Bell, great for programming, terrible for digestion.
Okay, so despite my best efforts, you can use a single responsibility principle to improve the quality of your JavaScript. But there is no way that you can apply it to HTML or CSS.
Some people, including our evil friend here, would suggest that HTML and CSS are really just cosmetic code. It's just the paint that goes on top of the real application. And if that's the case, what's the point in trying to apply leading principles to that code? Now, in the last episode, we talked about how ridiculous and dangerous that idea is. Just try convincing your product manager or your users that the UI code is not as important as the rest of the code. It's not going to go well. Every minuscule detail counts when it comes to the user experience. But more importantly, the user experience is often the part of the application that changes the most. Users and PMs are both big agents of change, and they want changes to the layer they interact with the most, the UI. Now remember, software is most valuable when it is flexible, when it's malleable. The ability to keep up with the market and to change with the times is what makes it most profitable. Now, when a UI is no longer able to be maintained and updated, that is the day that that project dies. Now, that said, I admit that single responsibility principle does not perfectly apply to HTML and CSS. After all, neither have modules or classes. Well, at least not classes in the object-oriented sense. Still, there's a lot of benefits that our code can get from the spirit of SRP. Let's start with HTML. One SRP-inspired rule would be to give every HTML element one job, and only one. It could be semantic or structural, it could be content or styling, but it should be only one. Let's take a look at some examples.
Here's a small piece of HTML that is fairly trivial, but it does demonstrate some of the subtle challenges of applying SRP to HTML code. First, we have this H1 here, this header. And the header has two classes associated with it. Do something on click, so apparently there's some JavaScript in play that is applying a behavior. And bright blue. This is probably a CSS class that is associating a blue color with this H1. Now, this looks fine, but it does raise the question, what is the relationship between this being a header, it doing something on click, and it being bright blue? Should the header in its entirety always be bright blue? Or is the bright blue more associated to a clickable blue header, this text itself? Or is the bright blue perhaps associated with a larger idea of header that if there were an H group and an H2 added to this markup, we would want that to be blue as well? Same question can be asked to do something on click. Do we just want this text to be clicked, and if there was something else that were added, we wouldn't want that to do something? Or do we definitely want the H1 to be doing something on click, and if there was an H2, we wouldn't want that clicked? Or maybe there's a missing idea of a larger header, and that anything inside of that header, whether it be an H1 or an H2, should also do something on click. And by asking these questions early, we're then able to change the markup in order to extract these different ideas apart and make sure that each element only has one job. So perhaps we decided that actually it's just this text that should be bright blue. And we can make this explicit by saying that there is going to be a span. And sure enough, just this text is going to be bright blue. And we're going to actually remove that from the H1. And similarly, perhaps our intent is for this entire header to be doing something on click. And so we want to add that here. And we want to remove it from the header itself. And now we have extracted these out from one another because we decided that they're actually independent. Sure, at the moment they all happen to be affecting the same element, the H1, but as we continue to move this application forward and we're making changes and maintaining this in the long term, we realize that the meaning of each of these items is separate. So next, let's move down a bit and take a look at these divs down here. So as you can see, we're using Twitter Bootstrap and the grid that it provides that gives us rows and columns in order to create a grid UI. On those same div elements that are rows and columns, we also have some IDs that seem to reference some kind of a domain idea. We have a set of my features. We have a feature X and a feature Y that means something in this fake application. And so, again, the question that we want to ask is that when we have multiple references that are on an element, how are these related? Is feature X always meant to be a column? Is it meaningful for my features to be a row? I'm guessing not. I'm guessing that what we probably want here is we want a grid structure that has rows and columns, and then inside of that, we would have features, and perhaps wrapping that whole thing is some kind of a container saying that these are all my features. But if we were to move, let's say, feature X out of this grid somewhere else on the page, that wouldn't change the meaning of feature X. Just because it's no longer a column doesn't mean that feature X is now inherently changed. We've just moved it around. Yet, to do that, right now, we would have to actually change the markup because it is both feature X and it is serving as a column. And so we, again, want SRP, a single responsibility principle, applied to these elements so that each one is only doing one job. And right now, it's pretty clear that it's doing two jobs. They're acting both as some kind of a domain object, some kind of a reference for JavaScript and for CSS styling, and they're acting as a structure in this grid structure, as rows and columns. So we can find more flexibility by actually breaking these ideas apart. So we can start by taking my features, and again, this is probably better implemented as a wrapper or container around everything. Inside of that, we could have a row, and now these would all be inside of the row. And we'll do something similar for these columns. We want to make these explicitly columns, where that's its entire job is just to be a column. We can do that here as well. And now as we look at this, we can see that we have successfully extracted these ideas apart. We now have divs that are meaningfully named, and they're labels that make sense in the context of my application. And then we have a grid structure. And we could change the grid without changing these meaningful domain objects. And we could change the domain without changing the grid. They are now completely decoupled, and we're achieving SRP. Each of these items has one single responsibility.
Another application of SRP to HTML has to do with view templating. Each view template is essentially a module of code, and it should have one job: rendering that HTML entity. Now, the template should not have business logic in it. That belongs in some kind of a presenter that could be independently tested and maintained. Let's take a look at a template that is trying to do way too much.
Moving on from that previous example, we're going to fill out feature X here and add a little bit of code that uses some dynamic values from elsewhere in the application. Now here we're using EJS, embedded JavaScript. It allows us to use these tags in order to execute some arbitrary JavaScript inside of a template. And the tags that have the equal sign in order to actually spit this out into the template when rendering happens. So we are saying hello to the user, and then we're going through some conditional logic in order to see what name should we use. We try using the nickname first if we have it, if not the first name. If we don't have that, then we check to see if we have title and a last name. We can say something like, hello, Mrs. Doe. And if we don't have any of that somehow, then we're going to fall back just to friend. Now in our templates, we really want to have a single responsibility. That responsibility is displaying HTML code. Now that may include taking dynamic values and plugging them in, but it shouldn't include this kind of logic. So how do we get this logic? Well, my guess is that somebody didn't just sit down and write this all out in one go. I bet what happened is that part of it was written. Time went on, we realized there was another use case and something got tacked on. Then the next thing got tacked on, and the next thing got tacked on. Maybe we started with first name, just using that. then realized that we might need to fall back to the title and the last name. And then someone added the idea of the nickname to the system, and so we figured we should probably use that. And then, of course, there was some weird situation this one time after a database migration went wrong, where we ended up with no name at all for somebody who was crashing the application. And so we figured, oh, we better throw in this last clause as well. Nobody really sets out to design code this way, but we certainly end up in situations that look exactly like this. Now, there's two problems with this. One is that the template does have two jobs. It's rendering HTML, and it has to know about how to prioritize one form of a name over another. But also, that logic is very difficult to test if it's locked inside of a template. When it's inside of a template, to test that, you need to render the template, parse out HTML, look for particular pieces of text to run assertions on. It's slow, and it's usually difficult to set up. However, if you're using something like a presenter object or a controller that has all of that logic, and then is just sending very simple representations of the data down to the template, that's very easy to test. You could just have a simple function that gives you a display name, and you can give it inputs, and you can see what the output is, and it's a piece of cake to both understand and to test. So what we would rather do is move all of this logic up into that presenter layer, and then simply use something like display name, which would be a dumb string value that was passed from the presenter down to the template, and use that directly here. We remove all of this logic, and it's very clear then what display name is, what we're doing with it, and how it fits into the template overall. Now, while it is true that choosing a name is display logic, it's not template logic. And if we're able to extract those two ideas apart from one another, display logic, which may very well belong at the presenter level, and template logic, which really does belong in the template, will be very well off. Now, EJS doesn't do anything to help you make those decisions. That's one of the reasons why I really like using Mustache. Mustache claims to be logicless templates, and sure enough, it doesn't really give you the ability to do much arbitrary JavaScript, for example, in the template. It forces you to use a presenter layer that does all of the logic, and then just use dumb values inside of your template.
Finally, let's talk CSS. Now, CSS classes aren't exactly the kind of classes that SRP is talking about, but there's still a lot of similarities. CSS classes should have one responsibility so that they will only be changed for one reason. There are many CSS systems and naming conventions that have been emerging lately, and one that has gotten my attention is BEM. BEM, or B-E-M, is an acronym for Block, Element, and Modifier. Through CSS class naming conventions, BEM keeps these three concerns separate, allowing them to be changed independently of one another. Let's go back to the HTML example and see if we can tease apart the tightly coupled CSS.
Returning to that previous example, we want to flesh out feature X a little bit. Let's say that we wanted the user to be able to update that display name. So we added a form that has a label and an input for name, and we added a simple submit button that starts out in a disabled state of some kind. We have a few simple styles. The form inside of feature X has its background color, an input that has a name attribute of name. It has a larger font size, and then when there is an input with the class disabled, it is going to get a gray text color. Now, these CSS styles do work, and frankly, I've been using this kind of CSS for years. It's the first thing that you reach to. You just have to build up these selectors that have the right level of specificity, and they eventually point their way to the elements that you want to style. The problem, though, is that we're building these selectors out of IDs and out of elements and classes that oftentimes are not explicitly there for the sake of styling. Feature X, for example, is this container, and that feature X might be used for semantic purposes, might be used for JavaScript purposes. Using it for styling is another job that I'm adding to that ID. Let's take a look at this attribute for name. Now, based on HTML, it's using the name attribute to decide when we submit the form what the properties are going to be called. We're going to have a payload that includes name in it. If we ever needed to change that payload, we would change that HTML attribute and this would break. We would have to then go back and change the CSS in addition to the HTML. Similarly, right now the submit button is an input with type submit, but what if we wanted to change it to a button? Well, we would have also broken the stylings. Not because we tried to change the style, but just because that input was doing two things. It was serving both as markup and it was serving for the sake of styling. This is why we want to introduce BEM. BEM gives us the ability to be very explicit about the class names that we're using to style our elements. Now, important thing to remember is that BEM is really just a set of naming conventions. That's all it is. It introduces three primary ideas, different kinds of elements that we're going to name differently. There's the blocks, there's the elements, and modifiers. So first, the blocks. Any element that is kind of self-sufficient. It might have children, but it doesn't require any kind of a parent in order to contextualize it, would be a block. So certainly feature X here would be a block, but I think form would also be a block here. I'd imagine that whatever styles we're applying to this form would probably make sense even if we moved this form outside of feature X. If we were to say, boy, I wish this were higher or this were underneath this set of my features, we would want to be able to maintain those styles. Yet, with the way that they're currently written, we wouldn't. The feature X reference would break and we would lose all of our stylings. Blocks are simply named with some kind of a meaningful class name that kind of defines their scope. So, for example, if the styles associated to this form were general for a form, then I would want to have a class equal to form, saying that this is applicable to anything that is a form. However, I think this is more specific to like the feature X form, and so I would include that as part of the class name. That way, this is something that is specific, and now when I come down to my styles, I am now explicitly using this class name. Any element that is inside of a block that isn't a standalone element is considered, well, an element. For example, this text field would be an element. Outside of feature X form, it doesn't really stand alone. It doesn't make sense. It's reliant on being inside of this form. And so the class name that we would use for this has two parts to it. The first part is that it actually uses the same block identifier, followed by two underscores, followed by an identifier for that element. So I would say text field. This entire thing then is the class name. And so as we come down here, we would use that. And now this is a very specific class that is telling us that it is styling the text field that is inside of the feature X form block. Now, I know what you're thinking. This seems very verbose, and yet it's very explicit. It explicitly tells us what we are styling. Finally, there are modifiers. Now, a modifier is some kind of an alternate state that a block or an element might get into. In this example, the disabled state of the submit button would be a modifier. Again, we're going to use a class to call this out, and the way that we would do this is we again start with the feature X form, which is our block name. We're going to use an element. This element would be a submit button. And then we're going to use two hyphens followed by a string that describes this state, this modifier, the disabled modifier. And that is one big class name that we're then going to use to explicitly refer to this particular state on a particular element inside of a particular block. So, yes, this is verbose, but I think it is worth the cost because of how explicit it is. Following the nature of SRP, we wanted to have a single responsibility for each of our classes, and this is one way of doing that. Every single one of these classes maps to a single idea, a single responsibility, a single style. By using BEM, we prevent some of the conflicts from happening when we're using selectors for multiple purposes. Each of these are used for only one reason, and because of that, while a little verbose, it ends up giving us a much more logical, much safer CSS codebase.
Well, that's a wrap for today. We've covered a lot of ground. We started off by talking about best practices versus leading practices, and how these practices are contextual and change over time. We talked about the single responsibility principle and how its intent is to reduce the number of reasons for change to just one. We then looked at command query separation and how it clarifies the role of a function to make it easier to use and understand. Once we're using SRP and command query separation, then we get to use Taco Bell programming, using functional composition to maximize the functionality while minimizing the code liability. We were even able to show how you can apply SRP to HTML and CSS. Well, that's one solid principle down, but we still have 4 more to go. Next up is the open-close principle and the Liskov substitution principle, so you will not want to miss episode 3. What's going on over there?
RM-RF/. Oops.
I really need to stop him. I'll see you next time on Clean Code in the Browser.
Remember, you've got the power to bring beauty back. Bring beauty back. Remember, you've got the power to bring beauty back. Bring beauty back.
Taco run!
No. No! 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 Come on! No! No! Why? 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 No! No! Why? No! Oh God! No! No!
You're gonna win an award for that.
That seems likely. Yes, that's what we're shooting for here.